Hello and welcome. My name's Eric, and today I will go over how to make a simple state machine in C Sharp, as well as an example of using it in a game. This state machine will be used in future tutorials and is very generic. It can be used with UI, effects, AI logic, movement, etc. Well, let's go ahead and look into the basics of a state machine. So we could think of the state machine as a class, and that class will hold a list of all the state that state machine can run. The state machine can only run one state at a time. The core state machine class's job is simply just to handle switching between and executing the base functions of the state. So let's think of a platforming character. That character can move, run, jump, and it can take damage. Now, taking damage or a hurt state, you may not think of very often, but you actually would probably want to do a lot of stuff when the player takes damage. Stuff like playing a certain animation, firing off some effects, and potentially you may not want the player to be able to take damage for a few frames after they've previously taken damage. This makes the game a little more easy, and even though it's technically not fair, it actually makes the game feel more fair to players. Now, these state actually will inherit from a base state class, and this class will have three functions that are going to be in all of them basically. So whenever that state is chosen to be ran, that it's chosen to be the current state, we're going to play this onInner function. After the inner function has been called, it's actually going to fire an event, and we'll get into these events later, but in short, other classes and other functions can listen to whenever this event is being fired. So you could have an animation class that's listening to the hurt state, for example, and it could play the hurt animation, and the player movement class that has all of this state logic, it doesn't have to worry about that, and you can completely separate these two functions. Then going on to the update will actually be driven by the physics update, and it will be called, I believe, 16 times a second by default in Godot. It will also fire an event the first time it's called. And the exit state is actually a really nice part with the state machine, because you may have created some data in the enter and update state, and you go ahead and delete that, clean that up in the exit state. You could also turn off some objects that you may have turned on. You could, destroy some effects that are being played or cancel a currently playing animation. So there's a lot of nice cleanup things that you can do in the exit state. And the exit state is called right before the onInner state of the next state that you're transitioning to. There's also an event that's played whenever the exit state happens. So now that we have the base idea of a state machine and states, let's jump on into Godot and, well, let's make our classes. So for this tutorial, I'll be using C Sharp. If you would like a tutorial based on GD script, definitely drop some comments and I'll be more than happy to make one. So I'm gonna have this folder here for the core state machine classes. So let's go ahead and right click, new script. Make sure that the new script is set to C Sharp and it inherits from Node. Now, let's start off and first make the simple state class. You may be wondering why we're not starting off with the state machine itself, and that's just because the state machine is heavily dependent on the state class to, well, exist. It's basically calling the functions in the state class, so it needs to be there first. So let's just go ahead and delete this boilerplate code. And first off, we'll need some Boolean variables just so we don't call the update state before the start state has been called, and we don't call the update state before onUpdate has sent its event. Now let's go ahead and declare our events. And if you're used to events in C Sharp, these do use delegate, but you'll need to add this signal tag so that the editor can display them, well, in the editor. This is really nice. It's similar to how Unity lets you connect events through the editor. I'll show you that later on whenever I show you this in my current project. But we'll need an event for state start, state update, and state exited. Okay. Now let's start with the onStart function. So I'm just going to copy it in from my current project. Okay, so this function is virtual because we'll be overriding it within each implementation of the state class. So we also need to declare that we're using the system, I believe it's collections. Yep, collections.generic. This will contain stuff like dictionaries and lists, but I believe we'll just need the dictionary for this class. So just to walk you through it, the first function that will be called in this state is onStart, and we will be emitting this state start signal. So anything that's listening for this will get to act upon it. Now we're not using this message in this base class, but I really like adding this to my state machines. You don't have to, but the reason I like using them is because on exit of the previous state, I may want to pass in some data for the next state to know about. For example, after completing a game in my tower defense game, we transition from the gameplay state to the game over state. And I'll pass in stuff like the player win, what was their score, how many rounds did they last. I could pass that into the game over state and then display the information to the player, you know, depending on if they won or lost, basically. It's very flexible. It uses object type, so you could basically just shove whatever you want in there. Now, let's go on and bring in the onUpdate. This should only be called once. It's making sure that onStart has been called before it, and it's also going to signal off the update state and then say that the update state has been fired. This is a really simple class. You probably won't need to override it actually, but it's virtual if you do want to. Now for the update state. The update state needs to be called every frame, well, every physics update by the state machine itself. And again, we're going to be checking to make sure that we have sent off the onUpdate signal first. I will, after we get done, show you how to override this and add your own code into the update state. But let's move on to onExit. So with onExit, we're going to get past the name of the next state. This is just here so that if you want to do one thing, if you're going to a certain state versus another, you can make that decision. If you don't want to, you could just ignore it though. Again, we're just going to check to make sure that this class has been initialized and the start function has been called before you exit. We're going to send off that event, and we're going to reset these variables so that whenever this state gets called again, onStart will be called and onUpdate will also be called. So we want to make sure those get set back to false. Now we could go on back to Godot and let's make the state machine. So again, make sure it's selected C# and inheriting from node. And let's call it simple state machine. Go ahead and open it up. Delete the template code, and let's get started. So with the state machine, I'm going to go ahead and throw in a couple of usings because I know just doing it now will be easier than grabbing them as we need them. We're going to need system.link, and again we're going to need system.collections.generic. We're also going to have some events. Now this is actually, I don't think super common with state machines, but I like to have the state machine to have its own events to be fired. That way, if you, let's say you want to do something every time your state machine has a new state that starts. You don't care what state it is, you just want to do that thing. Well, with these events you can. Now you can ignore these and that's completely fine. I just find them really useful when dealing with UI. So next up, we need to make a list of all the states. And we're just going to be declaring that. We're not going to be initializing it just yet. We'll need the current state and the last state. This will be so other states and their classes can check and see which state we're on and which state we came from. If you want to, you can make this to be a private set in a public get, and that will be a little bit safer. But for this demo of a simple state machine, we'll just leave it like it is. And then this one will be a little bit more protected. So we're going to have a protected simple state. We're going to default it to null, but we will soon be assigning it. First up, we're going to need to have a ready function. And in this ready function, we'll call the base ready of node. And after that, we're going to get a node beneath the current node that's called states. And then all the children of that node, you're going to want to make sure that all those children are simple states. If not, this should just ignore the ones that are not. But just for simplicity, only put your states under the state node. And we're going to throw all those into a list. This is actually the function, the of type, that we're using the link for. And you know what? Let me pull in my current game so that makes a little bit more sense. That may have been a little confusing how I worded that. So this is my game state machine, and underneath it we have a state node. This has no script on it, it just needs to be called state. And then underneath that, all of its immediate children nodes are inheriting from the state class. So that's what I meant. Anyway, moving on. We're going to want a function that allows us to set the next state. And this function is actually going to be private, and we're only going to call it from within the state machine class. We'll have another public facing function for changing the state, but let's go over this one first. So the set state function will take in a simple state, and it will take in a message. We're just going to do some sanity check. If the state that we passed in is null or there's a problem, we're just going to X out of this. We're also going to check for the case. So if it's not null, we want to call that we're going to exit the previous state. We want to call currently the current state's exit. And then we're going to do the post-exit event. And these are some of the events that are declared up here. Now, the reason we want to make sure to only do this if this is not equal to null, because if it's equal to null, there's not going to be a state to call on exit on. So that's why we're checking that. Next, we're going to set the last state to the current state, and we'll set the current state to the state we're going to be changing to. After that's set up, we can set the state to the state that we're changing it to. We're going to call the pre-start event, which is located here. And we're going to call the onStart function, and that's the one that we just made in the simple state class. And after that function's been called, we'll call the post-start event. And after that, we will call onUpdate. So it's probably starting to make sense why we needed to go ahead and set up that simple state first before making this class. But this class is actually very small, so we'll be done with it pretty quickly. The next function will be the public-facing way of how to change the state. So change state is the public-facing function on how we can change state. And we can actually call this from the other states as well. So how you can change state is you'll pass in the name of the state that you want to change to. And if you want to, you could pass in the dictionary. it's going to default it to null, and that's because most of the time I'm not using it, but it's nice to have it. So we're just going to go through all the states, and we're going to find the one which matches the string that we passed in. After we find it, we will call that private setState function, and then we're going to return. Now the last function is very simple, and that's that we just need to be calling the physics update process. We'll also be getting the delta for that. There will be a period of time between the state machine starting up where the state is equal to null, and we don't want to be calling that. So if the state is equal to null, just return out of this function. But if it's not null, get the current state and call update state and pass in the delta. Let's save that. Now let's turn to my current game that I'm working on, Stop the Slimes, and I'll show you some implementation of how I'm using this simple state machine. So here's a look at my current project, Stop the Slimes. I'm currently using a state machine for my game manager class. So let's take a look at some of these states. So first off, let's look at the state machine itself, and the game manager is inheriting from the simple state machine. And I'm actually overriding the ready state so that I can choose to get this game manager state. And let me explain why I have this game manager state and not just the simple state. So if you see, we have the game manager state here, and the only thing in the game manager state will be a reference to the game manager itself. What that allows us to do is that allows any of the other states to call the game manager, and if there's any functions in here, well, in this case there's not, but in other places that I'm using it, there are functions in the state machine that many of the other states would like to call, and so we have the reference there. Well, I guess there is one function. So all these states, they are actually going to call when they need to change to the next state. So even though that change state function isn't here, it's located in the class that we're inheriting from. And here we go. So this is the change state function, and this will be called from all the other states. So let's just go from the beginning. The first state is the start state, and we're just going to turn on all the UI elements on start, and on update we're going to listen for a UI click event, and after we get that click we'll try to change to the main menu state. If that was successful, on exit we're going to go ahead and turn off all those UI elements. Next up, let's look at the main menu state. So again, we're going to turn on all the UI elements. Then we're going to start the main menu music. On exit, we're going to turn off those things. This class will also be listening for a button press. And when that button's pressed, we're going to change the state to the game loop. And we're going to actually pass it all of this demo level data. So this is a good example of really using that dictionary. So we're going to pass it where it was called from. We're going to pass it what map resource to load. Then we're going to give it some level information, mainly on each wave, which enemies to spawn, and also how much time should it wait between spawning the next enemy. So as you can see, as we get later and later on, the time between spawning an enemy will get smaller. We'll also give the player some starting cash and a starting amount of health. These two values will probably be tweaked between the different demo levels to have some more difficult levels and some more easy levels. This state can also go to the options menu. There's also a Discord button here. By the way, you should check out the Discord if you have any questions from this tutorial. Drop by and ask away. So I could go on, but this should probably give you a good idea of how having these different states give a consistency to your code, but also keep the different components separate. As a final example, let's look at this game in action. So I'll just slide this over and we'll look at this remote area over here in the scene hierarchy. This will let us see, well, how our current nodes are looking. So it got the on click and it transitioned into the next state. Now go ahead and click on the demo and it's going to pass that level data like we talked about into the demo scene. We have our 200 gems, we have our current health as you saw. And the first round, well, the first round should have 2 enemies in it and they should spawn about a second apart. So let's check it out. 1, 2. Go ahead and drop that tower. Well, I really hope this video was helpful for you. If you have any ideas for future tutorials, if you would like to get this tutorial in GDScript, ask below and I'll definitely re-upload it with that language. But we will be using this tutorial as kind of a base on other tutorials to build on in the future, such as getting into some AI, some, machine gun turrets, cool things like that. So if that kind of thing sounds interesting to you, and honestly, if you stuck out this long in the video, you'll probably be interested in those future videos. So please subscribe and ring that bell, and I hope to see you next time. Bye.